Hi, I'm Miss Hall, and this is Lesson 16, Solving Quadratic Equations Algebraically and Graphically. In Lessons 14 and 15, we reviewed how to factor expressions, and now we're going to be solving equations. So there's going to be equal signs. And when we're solving quadratic equations, we can solve it by using one of three methods. We could graph, we could use square roots, or we could factor. I want to point out here that solving in a quadratic equation, the solution has many names. We can call it the zeros of the quadratic, the x-intercepts, the solutions. Did I put roots yet? It's the roots. Okay. So this is what we're doing today. We are finding the solutions to these quadratic equations, which is the same thing as we're finding the zeros. We're finding the x-intercepts. We're finding the roots of these quadratic equations. Example 1 is to solve by graphing. So to solve it by graphing, you graph the function. We get everything to one side of the equation if it's not. Then we set that 0 to y. So we're graphing y equals x squared minus x minus 6. And the solutions are where y is 0. In other words, the x-intercepts. So you can see they're clearly labeled. You won't be given a graph normally. You'll have to graph it. We have -2 and 3. So I can write the solutions as x equals, I'm going to use set notation, -2, 3. That is the set of numbers that x could be. X could be -2 and x could be 3. And so if you plug in -2 or 3 into the original equation, you'll see that it gives you 0. In B, in order to graph this, if the graph wasn't provided for us, you would first need to move over this 4x. So the equation would become -2x squared minus 4x minus 2 equals 0. Then you would change this 0 to a y and graph it. And then wherever y was 0, which is the x-intercepts, you would have your solution. It would be the x value. And here, x is equal to -1. There's just one solution, one x-intercept. Example 2, solving quadratic equations using square roots. Solve each equation using square roots. Example A, we are going to isolate that x squared, then take the square root of both sides to find the solutions. So 4x squared equals, I'll add 31, which will give me 80. Divide both sides by 4, I have x squared equals 20. At this point, I can take the square root of both sides. Square root, which leaves me with x equals. Now the square root of 20, because I'm the one that's adding that square root, I have to take into account both the positive and negative value of the square root of 20. And 20 isn't a perfect square. So the best I can do is simplify this radical. And what I do there is radical 20 is the same as radical 4 times radical 5. And radical 4, square root of 4, is 2. So I can rewrite the square root of 20 as 2 square root 5. And that's in simplified form. And I should represent it in simplified form. So therefore, x is equal to plus or minus 2 square root of 5. B, and try to isolate the x squared. So I have 3x squared equals -9. Divide both sides by 3, I get x squared equals -3. Take the square root, I get that x. I'll take the square root of both sides. X is equal to plus or minus the square root of -3. The square root of a negative number is not a real solution. There isn't a number squared a real number that when you square it will give us a -3. So the answer here is no real solution. And it makes sense that some of these quadratic equations are going to have no real solution. I'll show you 3 examples on a graph, right? It's the x-intercepts of a parabola. So maybe a parabola hits the x-axis twice. Maybe it touches it once. There's one solution. Or maybe it never touches. So there's no solutions or no real solutions, and that's what we got for part B. Now C. We need to isolate the squared binomial. So I'm going to get rid of this 2/5 by multiplying both sides by 5/2. And then I have x plus 3 squared equals 25/2. Now I can take the square root of both sides, which gives me x plus 3 equals plus or minus the square root of 25/2. I can take the square root of 25, which is 5, over the square root of 2, which it's not a perfect square. And then I'll have to subtract 3 from both sides, and I'll get that x equals -3 plus or minus 5 over the square root of 2. Now it's not good to leave a radical in the denominator, so I need to rationalize this term, 5 over radical 2. I don't want a radical in the denominator, so if I multiply it by radical 2 over radical 2, in essence I'm multiplying it by 1. But what that does is I get a 2 in the denominator and a 5 radical 2 in the numerator, and now I've rationalized the denominator. It's a rational value. So going back, I can rewrite my solution as x equals -3 plus or minus 5 radical 2 over 2. Example 3, solving a quadratic equation by factoring. Solve x squared minus 4x equals 45 by factoring. First step is we want to make one side equals 0. So I will subtract 45 from both sides, and I'll end up with x squared minus 4x minus 45 equals 0. Second step, factor. This is a factorable quadratic trinomial. X, looking for two numbers that multiply to -45 and add to -4, which is -9 and +5. Step 3, solve. This is where you use the zero product property. If you have two numbers that multiply to 0, one of those numbers must be 0. So we can put x minus 9 equals 0, or x plus 5 equals 0. Therefore, x is 9, or x is -5. And we can write x is the solution set of -5, 9. Both those solutions make it true. This work here is optional if you want to write out those steps, and in some cases it's easiest if you do, if it's not very simple to see what the x value is. But you can also just jump to x is equal to -5 and x is equal to -9. Don't jump to that. Jump to x is equal to -5 and x is equal to +9. In order to solve by factoring, I need to set one side equal to 0. So it gives me x squared plus 2x minus 48 equals 0. Now I can factor the left side equals to 0, x, two numbers that multiply to -45 and add to -2, +8 and negative 6. And now I can use the zero product property. So either x plus 8 equals 0 or x minus 6 equals 0. X is negative 8 or x is 6. Therefore, x is equal to 8 and negative 8 and positive 6.